Alright folks, in today's video we are going to talk about two major things. First is talk about what a conic section is and how they're formed and what's some of the basic terminology. The second major piece of information we'll learn about is called completing the square, and it's actually an algebra idea, and it goes back to factoring quadratics. It's something that we never really learned in Algebra 1 though, if you took Algebra 1 here at Warren. So we're going to go ahead and teach that concept as how to complete the square, what it means, and how I solve equations for that. We're going to then use that in future videos and lessons, especially with circles and writing the equations of circles. So when I say conic or a conic section, according to the dictionary, it's an adjective that means of or like a cone. And that's because it is sections of a cone. It's what happens when we take a plane and slice a cone. You can see here for our circle and our ellipse, they're very similar cuts, but most importantly, I take this rectangular plane and slice my cone across so that I am parallel to the base of the cone, and that's going to give me a circle. If I slice that same cone but on more of a diagonal, so it's no longer parallel, that elongates that circle, which is no longer a circle, and it's called now an ellipse. And if I slice it perpendicular to my base, I get, or such that I cut both of these cones, the one on top of the other. Doesn't necessarily have to be perpendicular. That's when I get a hyperbola. This is what those shapes look like. You see at the bottom we have our basic terms. All three of these shapes have a center. The circle, your center is going to be right in the middle here. And we'll talk in much more detail when we study each shape about what these mean, how I identify them, and how I find them. An ellipse is also going to have a center located in the same general area. But you can see the major difference here. This center is equidistant to the edge everywhere we go, whereas this center is not equidistant to the edge. And that's going to be an important aspect that we'll learn a little bit more about. For a hyperbola, your center is going to be directly in between your two different pieces here, or your two different branches of your hyperbola. Now, general terms will say that your center is at h, k. It's an ordered pair. It's a point. That'll become much more clear as we start looking at the equations for each of these in future lessons. Vertex. Now, a circle doesn't have a vertex, but an ellipse and a hyperbola do. In an ellipse, what the vertex is the end of your major axis. More on what a major axis is in just a moment, but if we go back up and look at our diagram here, I can tell you your major axis is going to be this segment here. It'll go through your center, but it's your longer of your two segments. So the vertices, or the vertex, is going to be the endpoints of that axis. That's going to be vertex 1, and that's going to be vertex 2. In a hyperbola, the vertex is the turning point of each branch. So I'll kind of put that in parentheses. Turning point of each branch. So when I look at the example up here, your vertices are going to be, here's one branch and it turns right there. There's a vertex. The other branch turns right there. There's your second vertex. So that's where your vertices are going to be. I'll call that vertice 1 and vertex 2. Focus. The focus is a point at which distances are measured. Now, the definition isn't going to be as important as how we find them in our shapes. And again, it's more specifically with an ellipse and a hyperbola. So it's a point at which distances are measured. And we'll show you examples as we get into the ellipse and studying it more, or the hyperbola. But generally speaking, it's going to be on your major axis in an ellipse. I'd call that F1 and F2 for focus 1 and focus 2. And it's going to be in the middle, or in between your hyperbola sections. Those are going to be your foci, or your focus 1 and your focus 2. That's how you can tell where your major axis is as well. So the major axis is that longer of your two axes in an ellipse. So I'll just write longer axis. It's the axis where that goes through the foci. So it goes through center and foci. The minor axis is the perpendicular axis to the major, and it's through the center. Scrolling up and kind of taking a peek at what that might look like. This is my major axis here. My minor axis would be this one, perpendicular but through the center. And that's going to be an important idea as we start studying ellipses. So, from here, what I want to do is start talking about this topic called completing the square. We're going to have to do this, especially with our circles section. And the first thing I want you to recall about completing the square is what a quadratic equation is and what it looks like in standard form. Standard form means we have an x squared term, an x term, a constant term equals 0. That's standard form for a quadratic equation. In all of our instances, we're only going to study standard form when a equals 1, so it's going to be x squared plus bx plus c. Now, a perfect square trinomial is called perfect square because when we factor it, we get the exact same factor twice. In this case, so Algebra 1 here, this is what we learned, how to factor this. My constant is 9. My coefficient of x is 6. What multiplies to 9 and adds to 6? That's 3 and 3. So when we factored this, we would get x plus 3 and x plus 3. Well, since that's the exact same factor listed twice, I can write it as x plus 3 quantity squared. That's why this trinomial, 3 terms, can be considered a perfect square trinomial, because when I factor it, it gets me a perfect square. I can make any trinomial a perfect square, though. And we can do that by completing the square. So, to do that, we need to figure out what constant term gives me this. This is a pattern. Completing the square is all about following a pattern. As long as your expression or equation is in standard form, we'll know what A is, B is, and we're trying to figure out what C is. So in this case, I know that B is 16. To find my constant term, I want to take B and divide it by 2, then square it. That's how I'm going to complete my square. Let's see if we can get the computer to not mess up. And we're back. So in this case, I know that B is 16, the coefficient of x. So I can calculate C by taking B, which is 16 divided by 2, and squaring it. 16 divided by 2 is 8. Square that, I get 64. So I know that C is 64. That means if I want to rewrite the expression as a perfect square, then as a square of a binomial, I have x squared plus 16x plus c, which I just found is 64. Now, in the past, we used to have you guys factor this with your x here, and you have 64 and 16 and what multiplies, but I'm going to tell you that we have done this in a way that this is going to be easier. b over 2, the number inside your parentheses up here, is the number that's used twice here. I know that 8 times 8 is 64 and 8 plus 8 is 16. I figured that out by calculating c the way we did. So I know that this is x plus 8 quantity squared. That's my perfect square. Example 2 here is the same idea, except this time b is negative. So b is negative 24. To find c, I take my negative 24 divided by 2 and square it. Make sure you use parentheses here. If you don't, you're going to get a mistake. When I square this, I get 144. Now, I have my x squared minus 24x plus 144. And the key difference between this problem and the one we just looked at, when I have a positive 16, I have an addition in here. Or when I have a positive coefficient of x. If I have a negative coefficient of x, like I do here, I'm not going to have x plus the square root here, or plus this. I'm going to have x minus 12 squared. Go ahead and get some practice here with numbers 1, 2, 3, and 4. Pause, try them, and then unpause to check your work. So numbers 1 and 2 are very similar, but the key difference is this is a minus 2x, this is a plus 2x. The value you get for c is identical because negative 1 quantity squared is still positive 1. Make sure you're using parentheses. If you don't, you will get a negative 1 there, and now it's not a perfect square. So the major difference then is this becomes x minus 1 squared, quantity squared. This is x plus 1 quantity squared. If you haven't finished 3 and 4, pause now and do so, please. So hopefully we got x plus 7 quantity squared and x minus 15 quantity squared. So when I'm finding c, it's always b over 2 squared. In this case, I get 49, but I always take this step in the middle instead of just putting it in my calculator like that, because that's going to tell me exactly what I need for down here. That will always match up once I simplify that fraction. Again, I knew b was negative 30. Divide that by 2, I get negative 15, and I have a minus 15. That's going to be how I complete the square. At this point, I'm going to do a second video to work with these examples and practice problems on solving using completing the square. So you can go ahead and stop this video, watch our second video in this section, and then you can try your practice problems.